So now we're going to look at a few examples of these. In letter A, I want to graph the solution y is less than 2x and y is greater than or equal to negative x plus 3. Well, I'm going to do these in two different colors, and I'm going to start with that first one in red. My y-intercept is 0, my slope is 2, so up 2 over 1, up 2 over 1, up 2 over 1. I think that's good enough. Use a ruler to connect the dots. We're going to use a dashed line here because it's just less than, not less than or equal to. And we're going to shade below that line. So everything under here would be a solution to that first inequality. Next, I'm going to do the other one in blue. Y is greater than or equal to negative x plus 3. I'm going to start at 3. My slope is negative 1, so down 1 over 1, down 1 over 1, down 1 over 1. I'm going to connect the dots with a solid line. Greater than or equal to, so I'm going to shade above that line. And all the points in the overlap, in the region that's red and blue, are solutions to this system of inequalities. I'm going to outline this region. I have a dashed line on this boundary and a solid line on this boundary. And then I'm just going to darken it in. You need to make it very clear to me what is the final answer. I don't really just want to see overlapping colors. I want the final region really darkened in. And that's our solution. All the points here will make both inequalities true if you were to go to plug them in. In letter B, well, that second inequality already looks good, but the first one, since it's in standard form, I should do some algebra to convert it. So we had 2x minus y is greater than or equal to negative 3. I'm going to subtract 2x from both sides. Negative y is greater than or equal to negative 2x minus 3. I'm going to divide everything by negative 1. And when we do that, we get y is, nope. Remember, when you divide by a negative, you need to flip that symbol. Almost caught me. Less than or equal to 2x plus 3. So now I'm going to graph and shade that inequality. I'm going to do that one in red. I'm going to start at 3. I'm going to go up 2 over 1, up 2 over 1. I'm going to backtrack as well to get a few more points. Down 2 over 1, down 2 over 1. Connect the dots with a solid line. And then we're going to go and shade below this line. Again, make sure you're extending your shading to the edges of the grid. The other one was already in a good form. So in blue, I'm going to start at 1. My slope's negative 1/2, so down 1 over 2. Down 1 over 2. I'm going to connect the dots with a dashed line this time. And it was greater than, so this time I'll shade above. Pick out the overlap. Looks like, again, it's going to be in that top right corner. Solid line boundary over here. Dashed line boundary down here. And make sure you darken in that region to very clearly show where all the solution points are going to be. In letter C, neither of them are in slope-intercept form, so I have some algebra to do with both of them. Negative x minus y is less than or equal to 2, so I'm going to add x to both sides. Negative y is less than or equal to x plus 2. Divide everything by negative 1. I'm running out of room, so I'm going to come up here. And this becomes y, flip your symbol because you're dividing by a negative, is greater than or equal to negative x minus 2. That's our first one. The other one was y minus 2x is greater than 1. All we have to do here is add 2x to both sides. And we're going to get y is greater than 2x plus 1. So these are the two we need to graph now. I'll do my first one in red, starting at negative 2, down 1 over 1, down 1 over 1, down 1 over 1. I'm going to use a solid line to connect dots. Greater than or equal to, so I'm going to shade above that line. And the other one will start at 1. My slope's positive 2, so up 2 over 1, up 2 over 1, up 2 over 1. Connect them with a dashed line. And we'll shade above once again for this inequality. And to pick out the overlap, this time it looks like the top left. So solid line boundary there, dashed line boundary over there, and just darken in that region. One more. We need to solve that first inequality for y, so 3x plus 2y is greater than 6, minus 3x minus 3x. 2y is greater than negative 3x plus 6. Divide everything by 2. And we're going to get y is greater than negative 3 halves x plus 3. And that second one's already okay. I'll deal with that one in a moment. But to graph that first inequality, we'll start at 3. We'll go down 3 over 2, down 3 over 2, down 3 over 2. Dashed line. And it's greater than, so I'm going to shade above the line. Then, for that second one, x is less than or equal to 1. Well, if it was x equals 1, that would be a vertical line, so I need to draw a vertical line at an x value of 1. I'm going to use a solid line because it's less than or equal to. And since I can't do above or below here, just like in the last section, less than or equal to 1 is just going to mean to the left of 1, all the x values that are less than 1. So I'm going to shade over here. And my final region looks like this top part over there. So outline it, dashed line over there, solid line on that boundary, shade it in, and we're good.